Hello and welcome back to another video. In this problem, we're asked to find the domain of each of these functions. In A, we have f of x is equal to 1 minus e to the x squared over 1 minus e to the 1 minus x squared. So the only restriction on this domain, because we're dealing with exponentials, which have a domain of all real numbers, is that the denominator of this fraction can't equal 0. So if we just solve for x in this function, then we can get our domain restriction. So if we add e to the 1 minus x squared to both sides, this cancels and we're left with 1 is not equal to e to the 1 minus x squared. What do we do here? Well, 1 is equal to e to the 0. And if e to the 0 cannot equal e to the 1 minus x squared, then their exponents also can't equal each other. Moving back up here, 0 cannot equal 1 minus x squared, just rewriting it. Now we can do this a more complicated way, or we can just use the fact that this is the difference of two squares, right? 1 is equal to 1 squared. So this is 1 minus x times 1 plus x. And if this times this is equal to 0, or can equal 0, then either this can't equal 0, or this can't equal 0. Either way, we got our answer. The domain of each function is all real numbers, but x cannot equal 1 or negative 1. This is for A. For B, we have another fraction. And again, the only restriction here is that the denominator cannot equal 0. Right? Cosine can take any values, e to the x can take any values, this polynomial can take any values. Only thing is that the denominator cannot equal 0. However, for no value of cosine x, or any value of any variable at all, is e to that value equal to 0. Therefore, there are no restrictions, and the domain is all real numbers. From negative infinity to positive infinity, any value will produce an output for this function f.